confirm if you are hearing me clearly. Okay, thank you so much. Thank you for confirming that. And I want to welcome everyone to my lecture today. Today, basically going to walk everyone on logistic regression that we actually started the other time. But before I go into today's lecture, basically, I want to make an announcement. The announcement is I've already canceled the assignment for the week. Okay, there's going to be, I'm going to send an announcement through an announcement section about that. I eventually canceled the assignment for the week. I wanted to, I delay the posting of the assignment because of Independence Day. I wanted to actually upload the assignment Tuesday, but I realized that that would disrupt the activity, of a Sunday to Sunday assignment, So that is the reason why it's okay. You're basically going to use this time to actually reflect on what you've done before. Okay, so there's not going to be any new assignment this week. Okay, so give me 1 second. I'm gonna open my lecture slide now. So I started logistic regression part 1 yesterday, and of course today I'm going to continue with that. So logistic regression part 2. Okay, so logistic regression, of course, we basically use logistic regression when we're trying to characterize relationship between variables in such a way that the nature of the response variable is categorical. I'm going to say that again. We use logistic regression, when we make an attempt to characterize relationship between variables in such a way that the response variable is categorical. For you to use linear regression, it is required that the response variable should be continuous. And of course, yesterday I demonstrated why you cannot use linear regression when the response variable is categorical. Of course, you saw there's going to be a kind of violations, you know that, right? There's going to be, violations of linearity. There's going to be violations of normality. There's going to be violation of constant variance and so on like that. I think I demonstrated that yesterday. And apart from that, your prediction is basically going to go out of bounds. Okay, you are not going to have something, that's actually bound in the 0 and 1. It's going to go over, it's going to, you can get something less than 0 in your prediction. You can get something greater than 1, which doesn't really make sense. And therefore, I presented yesterday logistic regression model that can actually handle that curvature in the data. Okay, so if you remember what I did yesterday, I think I want to have a kind of review between linear regression and logistic regression. Of course, if you take a look at this part, this is simple linear regression. You can say Y is quantitative, Y is continuous, okay? And of course, you can actually see this guy here, the population regression model. Okay, so take a look at that. But when you come to this side, Y is binary, which can take either 0 or 1. Okay, the levels of the categorical variable, okay, will be coded as 0 or 1. Okay, So if you take a look at what I have now, okay, uh, the nature of the response is binary. And if the nature of the response is binary, of course, you are no longer going to use linear regression, but what you're going to use is basically going to be the log horde. Okay, it's going to be in this form, and which I showed you yesterday, that this is a generalized linear model. Okay, generalizing logistic, generalizing uh, linear regression will actually lead to, logistic regression. Okay, so there's something I want to tell you now. When you have in logistic regression, you have a probability. There are three things that we normally use: probability, odds, and the log odds, right? Okay, because you apply for student loan, you may want to know what is the probability that you're actually going to be considered, or what is the probability that somebody have a particular disease. Okay, so the probability is actually used when it comes to logistic regression. You get what I mean, right? So probability is actually used. And you know what, that probability, we've already said that the expected value of y given s is the same thing as p, just like what I showed you yesterday. And what is the range of that? The range of probability is between 0 and 1. Take a look at that, inclusive. Because here we're trying to say 0 and 1. 0, probably 0 for maybe not giving, and 1 for giving. Okay, the probability that your loan will be considered, we can refer to that. Okay, so when your loan is considered, we give that 1. When it is not considered, we give that 0. Okay, so take a look at that. But when we're talking about odds, odds is more or less like you're talking about the ratio of the probability of success to the probability of failure. And of course, success and failure are mutually exclusive. You know that, right? And the range is basically from 0 to infinity, okay, for the ratio of the odd, okay, when you take a look at that. And when we talk about log odd, on the other hand, okay, if you look at it between this and this, it's just as talking about the log of this guy here. And don't forget, the log of that is what we actually equate to the linear regression model. Don't forget, when you come back here, you're basically going to say the log odds is equal to the linear regression expression. Take a look at that. And what I'm trying to give you here is just like, okay, when I take the log of the odd, okay, the log of the odd ratio, we actually, the range is going to be negative infinity to positive infinity. So the essence of this table here is just to show you what the range of probability can be, what the range of odds can be, and what the range of the log odds can actually be. Now, going by the example that I cited yesterday on the, something that was actually launched and there was a kind of damage. Okay, it's either when you have a launch like that, it's either there's a damage or not. And you know what we did yesterday? We look at the effect of temperature on that. Okay, and if you fit a straight line, if you fit a linear regression, of course, with the consequence of that. Okay, it's basically going to go over the range of 0 and 1. This, take a look at that. Okay, so which means getting this model now is not going to be, it's not going to work great. If you take a look at that now, this is not going to work great at all. Okay, because of the fact that, the linear relationship does not really fit in. And then by the time we now consider logistic regression, okay, this is what we actually going to have. Look at the curve here. Okay, it's basically going to be within the band, the bound like of 0 and 1. Look at that. And of course, from here, I showed you yesterday, we actually going to have a fitted model. Don't forget, there are two forms of logistic regression model. Okay, this is the probability form, and this is in logit form. Okay, in logit form, you are actually relating the log of the odds ratio, okay, to the conventional linear regression. Look at that. And this guy here in probability form, if you know the values of a predator now, you can actually predict the probability. For instance, if I want to predict the probability that the whole ring will be damaged, okay, given any temperature, I only need to plug in temperature to replace X, and I'm actually going to compute that. When the probability is very close to 1, you know what that means? It means the probability very close to 1 actually saying there is a high chance that the whole ring will be damaged. Don't forget, um, we actually, whole ring damage, we actually put 1, and not damage, we put 0. Okay, I just wanted to take notes of that. Okay, so, and the range of probability is basically from 0 to 1. I just wanted to take note of that. Okay. Okay, so if that happen now, the next thing I basic can you give me 1 second? Just 1 second. Okay, now I'm back. Now, based on what we have, you remember, I told you yesterday, because of the fact that the beta is actually negative, okay, the expected log or the probability, they're always going to be in the same direction. Now, we may want to investigate what happens when the temperature increases, okay? So that depends on what you actually have as your beta 1, okay? The beta 1 is negative 0.232, right? So if I actually want to look at the behavior of the log odd, the behavior of the odd, I want to know what, when temperature increases, what we actually, what is going to be the behavior of the expected log odd. I may also want to know what is going to be the behavior of expected odd. I may also want to know what's going to be the behavior of probability. And I'm going to tell you they're all going to be in the same direction. They're going to move in the same direction. Okay, so I said decrease here because of the negative on the beta 1. So the expected log odds of having O-ring damage will decrease. Then the expected odd, you can see that there's no log here again, right? Removing the log, when the log go to the other side, it's going to be turned to exponential, the law of mathematics, right? Okay, there's a difference between the expected log odd and the expected odd. I just wanted to take note of that. I'm going to say that again. There's a difference between the log odd and the expected odd. Okay, and that's what you're seeing here. But let me tell you, they're all going to be in the same direction. Now, when you come to the probability, okay, I showed you the other time that we have two ways of presenting regression logistic regression model. And we can present that in logit form, we can present that in probability form. In probability form now, I'm also going to say the expected probability of having O-ring damage will decrease. So, and what I just what I talk about now, the takeaway here is just going to be, okay, the log or the odds and the probability, they're all going to go in the same direction depending on the sign of the beta 1, okay, that you see in the logistic regression output. If the sign is positive, they're all going to be increased. If the sign is negative, they're all going to be decreased. I just wanted to take note of that. Okay, so I think the next thing I want to do now, how can we interpret the model coefficient in logistic regression? We did the same in linear regression. After estimating parameter in a regression model, the next thing is basically to interpret that. Okay, so after getting our model now, put our model in place, and how can we actually interpret? And let me tell you this, under logistic regression model, you're basically going to have three forms of that. Okay, though two forms are very common. The two forms that are very common, you talk about the log odd and the probability form. The log odd is what we call the logit form. Okay, but you can also have a odd. Of course, the odd is just like, okay, removing the log. When you remove the log from here, what happened? The log is going to become an exponential here. Take a look at that. So we're basically going to have three forms, generally speaking. Okay, which is going to be the log odd, odds, and probability. Okay. Now the question now is, how do we actually interpret the model coefficient? Now, the other time, anytime you want to interpret, they similarly, if you compare what we did, even in the linear regression model, if you want to interpret the slope, you're basically going to say, for every unit increase in the predictor variable, what happened to the other one? So what we're going to say now, when the temperature increases by 1 degree, what happened to the log odd? Okay, of course, I told you the other time, because of the sign on the slope, they are going to be decrease. But specifically now, if I want to interpret, is the minus is 0.232 here on the log odd. Of course, you know where I got this from, right? These are from the logistic regression output. Okay, this is the beta one. And sorry, this is the. I think I'm going to write something now. So this is the beta naught curve, right? The one you got from the logistic regression output. And this guy now is basically the beta one curve. And you know what? From the logistic regression output, we normally call them, we don't just call them estimates. You know what we call them? We call them log odd estimates. I want you to take note of that. We call them log odd, okay, estimates. Okay, we call them log odd estimates. That's what we call them. Okay, log odd estimates. That's what we call them. I just want to take note of that. Okay, so if I now want to interpret the negative is 0.232 now, then I'm going to say when the temperature increases by 1 degree, look at what I said here, log odd, because what I want to interpret is just this guy here. Okay, I'm focusing on the log odd model. Okay, I'm basically going to make reference to, I'm just say log odd of having O-ring damage is expected to decrease by 0.232. Okay, you can see that I've already reported the magnitude of that decrease. Okay, so take a look at that. And when I'm reporting that, I'm going to report that in an absolute term. That's why you see the absolute value of that. The idea behind the absolute term is just to convert the negative value to positive value. You can see that now. Now, how do I interpret this guy now? The one that has to do with odd. I want to tell you, don't forget, we got this odd from the first equation. From the log odd, we got this. All what we did is we moved the log to the other side. And when the log comes to the other side, it becomes the exponential. Take a look at that. So you derive this from the first one. And how do we also interpret that? Okay, so what are we going to do when we want to interpret that? Now, when we want to interpret that, we actually have a special formula for that, which is actually this guy here. Oh, give me 1 second, which is this guy here. Look at that. You see that? Okay, what we're going to do, you're going to take the exponential, okay? you're going to take the exponential of negative. You can use a calculator for that. 2, 3, 2. Okay. Then whatever you get here, you're going to subtract 1. Then you take the absolute value. When you do that, you're actually going to have like maybe 0.207 stuff multiplied by 100 is basically going to give you 27.7%. So which will represent the odds of having or ring damage. So the odds of having or ring damage is expected to decrease by 20.7%. You saw the way I calculated that, right? Okay, so by making use of the formula right here, you already know what your beta 1 is. Your beta 1 is negative 0.232. All what you just need to do is just to grab your calculator and figure that out. Okay, so if that is taken now, okay, I'm basically gonna move to how do we now do the one for probability. Okay, how do we interpret the one for probability? Okay, we've already done the odds of decreased by 20.7%. But before I go into the one for probability, some of you may be wondering on how do we end up using this guy here. I know some of you may be wondering, you may want to ask, why do we have to use this for the odd? Okay, now don't forget, when you are talking about the odd, okay, this is the equation, right? The odd, okay, don't forget we get the odd from the log odd. You get what I mean? Now, I'm going to demonstrate something to you now because we've been talking about when the temperature increases by 1. Okay, what happened? Now let's consider increase of 1. I want to show you how this is actually derived. Why do we have to use this? Okay, and I want to demonstrate with this. Now let's say we have odds 1. Okay, we wrote this one and just plug in x1, and we write odds 2 and we plug in x2. Okay, and we want to find the ratio of the two. Okay, that's what we have here, right? Okay, this is initially I was in x1 and now I'm in x2. Now, and I want to tell the world, like, okay, this x2 is like x1 plus 1, like, okay, increase of 1 unit. You hear when the temperature increased by 1 degree, right? Okay, so that is why the x2 now, I'm going to say, okay, x1 plus 1, like you have x1 and it goes up by 1 unit. Okay, now when you do that, I'm actually, instead of x2 now, I'm writing x1 plus 1. So I'm going to plug in x1 plus 1 to replace x2 here. That is why you have this. Now, when you have this guy now, you can actually expand that. This multiplied by that gives you that. This multiplied by that gives you that. Then you can now have an opportunity. If this is basically what you have now, look at that now. Okay, this is what you have now. Okay, now this is this, that is that. Okay, I can rewrite the whole thing here as exponential carry this guy. You know why? Because this guy and this guy, they are the same. I can split it out so that I can split this guy to be this. Look at that, mathematically speaking. So that what I'm going to have now, so this guy is going to cancel out this guy. What do you now have now? You have this guy, right? Which is what you have here. Now take the exponential of that. Okay, when you use a calculator and you take the exponential of that, it's basically going to give you this. Okay, now when it gives you this, okay, you have 0.793, which is more or less like 79.3%. Okay, now because don't forget the other time it was a negative, right? It means initially we were in 100%. We were in 100%. Now we find ourselves in 79.3%. Now what would be the decrease? The decrease now is just going to be 100 minus 79.3%. Okay, that will be 100 minus 79.3%, which is going to be 20.7%. If you want to look at that, Initially, it was assumed that when we were in X1, it was 100%. But now that we have an increase, when X1 now add 1 to that, okay, X1 plus 1, okay, that we now have X2 now. What has happened to the 100%? The 100% has gone down. Look at this is 79 point, this 0.793. If you multiply it by 100, that will give you 79.3%. If you want to know how much does it go down, subtract that from 100%. Okay, so you can, but if you want to keep going, if you have the 0.793 now, okay, now if you want to look at the percentage change, if you take a look at this guy here, it's more or less a formula for percentage change. Okay, if you want to talk about change, okay, for instance, the new minus old over the whole. You remember percentage change, but they're gonna say new, okay, minus old, you know that, old, right? New minus old. If you remember in high school, divided by old. If you want to talk about percentage change, so it's going to be the odd x2 minus odd x1 divided by odd x1. Take a look at that. Okay, so and the moment you do this minus that, don't forget, okay, what was your odd x2 and what was your odd x1? If you divide it by that, so it's more or less trying to tell you subtract this from 1. So that minus 1 that I called the 100% the other time, and that will give you this. Why do I have a negative? Of course, I have a negative because we're talking about a percent is decrease. Okay, decrease. That's a decrease. Okay, so that is why you have the negative that you have right now. Okay, now you can now see the reason how we derive that how, but let me tell you this. Anytime you want to interpret hard, don't forget the takeaway. Let me tell you, for log hard, you do this. For hard is this guy here. Please take notes. Okay? For log hard, it's going to be the absolute value of beta 1. And don't forget, it was negative before. Just going to be in a positive way. Take a look at that. So the log odds of having no ring damage is expected to decrease by 0.232. And the odds of having no ring damage is expected to decrease by 20.7%. So is there anyone, maybe probably you need a kind of clarification on that? Is there anyone? Okay, so if that is clear to you, I'm actually gonna move to another example. We're still on logistic regression model. So right now in this example, we want to look at smoking relationship between smoking and mortality. So how does smoking relate to mortality? Okay, women were interviewed about whether they smoked, and the outcome variable record whether each woman was still alive 20 years later, okay, during a follow-up study. Okay, 20 years later. Okay, so that means they were interviewed like 20 years ago, and the question they asked them then was, okay, do you smoke or not? And because we want to look at the effect of smoking on on mortality, and because of that, the outcome variable is either you going to be alive or not after that 20 years. And they also put into consideration their age. Okay, don't forget, it's not only smoking that actually could brings about death or being alive or being dead. Okay, age also very crucial variable too. Okay, so if you take a look at this guy now, if you look at case 3, I said for instance, case 3 was 71 years old at the time of the interview, and 20 years later she was no longer alive. Okay, here the response variable, the outcome, when somebody is alive, we actually coded as 1 and 0 for dead. Look at that. Okay, so Don't forget they were interviewed 20 years ago, and after 20 years, of course, we actually want to see the outcome, whether they're going to be alive or not. Take a look at what we have. So the case study now actually telling you, so which means uh, the age of this person now will be 91, okay? Because they were interviewed when 20 years earlier. Okay, so now the age here is just like the age then, the age during the interview 20 years ago. Okay, so right now this guy is going to be 43, and she's still alive. 43 alive, she smoked. Okay, as at that age, it was that person was 23 years old. Okay, when they were doing the interview 20 years ago. I just want to take note of that. The age that you see here is not the current age. It's the age as at the time of the interview. Take a look at that. Okay, because of the fact that if you're given something like this and they actually want you to figure out what is the relationship between smoking and mortality, because of the fact that the outcome variable, the response variable is categorical. This is categorical because it has levels. Then your appropriate regression model to use is logistic regression model. Excuse me, I just wanted to take note of that. I also want to let you know there are more than 6 people that were interviewed. There were about, I think, 1,314 cases. And we're only showing just the first 6 here. Okay, like I said, we're going to use logistic regression model to predict the outcome based on smoking status and the age. At the first interview, like I said, this is the age at the first interview, okay, not the current age. The person that is no longer alive after 20 years, okay, maybe actually die at the age of 91. You know what I mean? Okay, now, looking at the variables like this, and we have a kind of way to investigate, uh, relationship between the outcome and the predator, so that we can actually make an inference, statistical inference. No statistical inference, more or less like taking judgment using the relationship. Okay, we want to have a way to predict. That's what I mean. Okay, so like I said, the nature of the outcome variable will determine the type of regression to use. And because the nature of the response is categorical, you can say you got 2 levels, alive or dead. We coded alive as 1. We coded dead as 0. We're actually going to use logistic regression model. Okay, so if you take a look at what you are actually seeing here, it's more or less like having a plot between the outcome variable and age. Okay, if you take a look at what we have now. So between the outcome variable and age, and as you can see, you know, we also put into consideration those who smoke and those who do not smoke. So we got to predator. Okay, age is one of them. Age is continuous, and another predator is smoking, which is categorical. It has levels, 2 levels. Is that a smoke or not? And we also have the response, dead or alive, which is also categorical. Now, if I want to run this in out, oh my God, this is going to be this is the code. Look at the code right now. Okay, that is the code. Okay, when I actually imported my data set into R, okay, I have a smoking study, right? That is the name of my data. Okay, if I want to do the logistic regression model, don't forget I said I'm going to write the GLM, okay, the generalized linear model. Then the outcome variable, okay, I'm going to take that on age, then on the smoker, then I'm going to indicate family equal binomial. Of course, I'm indicating family equal binomial because the response variable is categorical. Okay, so I'm basically going to have this regression output. Okay, can somebody tell me for extra credit Why is it that we have a smoker yes? What happened? What do you think Arrow has done here for Arrow to declare the smoker yes and not smoker no? So what is going on? Can somebody tell me what is happening for extra credit? I'm talking about this guy here, this smoker yes. Okay. So what has Arrow assumed for Arrow to declare smoker yes? Don't forget, we could have smoker yes or smoker no. Okay, because the smoking is categorical. Can somebody tell me why is why does it display smoker yes in the output for extra credit? I need everyone to confirm again if you're still hearing me clearly. Is everyone still
Yes.
hearing me? Okay,
Yeah.
thank you so much.
May
Thank you
I
for
try?
okay, go ahead and try. Yep.
Yeah. So if smoker yes, it will be equal to 1. If smoker no, it will be equal to 0.
Okay, so which means what you are telling me now, Arrow has automatically coded smoker yes as 1 and smoker no as 0. Is that what you mean?
Yeah.
Good job. Oh my God. Okay, I'm going to do something now. Thank you so much. You've really done a great job. Send a message to me for extra credit. Okay, so thank you for sharing that. Okay, the smoker yes appear when when you are working with a categorical variable that have levels. If a particular level actually appeared in the arrow output, the other one that did not appear was actually coded as 0. Now the smoker here that is appearing now is being coded. It's trying to tell us it's being coded as 1. Okay, now based on this, now if I actually want to write my fitted module, don't forget there are 3 fitted module you can write out: the log odd, the odd, and the probability form. I'm going to say that again: the log odd, the odd, and the probability form. Now this is a log odd. Take a look at that. That is a log odd, right? That's a log odd. We're actually taking this to 2 decimal, right? Take a look at that. 7.60 minus 0.12H minus 0.20 smoker. Yes, this is the fitted logistic regression module now, which is a log odd. If I want to write, let me tell you, let's say you want to write that, then if they say they talk about hard, you know what you're going to do? Hard. This is going to be cancelled. And here on all of this, there's going to be exponential carrying all of that. Okay. That will be representing hard. Take note of that. Okay. That will be representing hard. But right now, I'm not interested in that. I'm only interested in logod. And that is what you have. Take a look at that.
Can you explain
Oh, somebody
something?
want to ask a question?
Yeah, can you explain
Okay, go
something?
ahead.
Why are you not interested in the odd version? Why are you only interested in the log odd?
Oh my God, that's a very good question. Well, very often, we normally consider 2 form of logistic regression model: the log odd and the probability form. The reason why we normally consider the 2, I'm going to tell you. If the proper logistic, when I talk about logistic regression model, okay, it is actually this guy here, log, okay, when you look at the model, right? Log of y cap divided by 1 minus that, which is the log of odd ratio, equal the beta naught, okay, plus the beta 1x. That is a traditional logistic regression model. And you know what? The estimate that you see here, okay, do you know what we call them? We call them log odd estimates. You can say that everything is on log odd. Log odd, we call them log odd estimates. They are not odd estimate, they are log odd, log, okay? Because that is a traditional logistic regression model, okay? Now, after that, The next one, the next module that we now consider is a probability module. You know why probability module? Because logistic regression module is a classification module. Okay, you apply for something. What is the probability that you're going to be given? Like in this question now, we need, it is not only the log odd here that we need. We need the probability module as well. The probability module is going to be, okay, if somebody smoke and I know the age of the person, what is the probability that the person will be alive? Don't forget, alive is 1, dead is 0. Okay, if you go back, give me 1 second. I'm going to clean up this now so that you can see. You know, when we're doing the coding, okay, alive is 1, dead is 0, right? Okay, so we need probability model because of the fact that we want to take a probability decision. The classification involves using probability. So you can now see the reason why we consider the log odd and the the probability form. But we can also talk about the odd too. Okay, like the odd of this to that, we can also do that. But very often, you're always going to say the log odd and the probability form. Does that make sense to you right now?
Yeah.
Thank you so much for for answering that question. Okay, now the question now is, don't forget, we got to play it all in this model now. Now, how do we interpret module coefficients? When I say module coefficient, how do we interpret the 7.60 here? How do we interpret the negative 0.12? And how do we actually interpret the negative 0.20? Now, I'm going to start with the interpretation now. And you're basically going to see my interpretation. You know, I want to interpret the coefficients, the slope coefficient associated with age. Okay, so how am I going to interpret that? I told you the other time, if you want to interpret that, what you're basically going to do, you're going to consider the exponential raised to power beta 1. I'm going to show you here. Take a look at that. Do you see this guy? So that is where you are interpreting that from the log odd. Okay, you're going to be absolute value of the beta 1 because we are interpreting that from the log odd. Don't forget what I have here. Okay, what I have here is a log odd. You see that? That's a log odd, right? If I want to interpret this guy now, okay, it's going to be exponential raised to power that. Then in absolute term, that is exactly what I'm doing here. Look at that. Use your calculator. You do the exponential raised to power that. Okay, so when you do the exponential raised to power that, whatever you get, you take the absolute value. Okay, so this one here, give me 1 second. This one here, this is the one here is for the odd. But if I want to talk about the log odd, I'm talking about for the log odd, don't forget it is exponential raised to power beta 1. Okay, now what I'm trying to say now, so exponential raised to power negative is 0.12 in absolute term. Okay, so that will give you 0.89, right? So that would be 0. So when you take the exponential of that, okay, you actually gonna have that. Okay, now if you take a look at this, give me 1 second. If you take a look at this guy now, okay, the log odd, okay, interpreting that now. So if you want to interpret this guy now, I'm going to tell you what you're going to do. Like you want to interpret the log odd. You know what this guy is trying to say? He's trying to say, if you hold smoking at constant, okay, if age increases by 1, okay, I'm going to say that again. If you, let's say for instance, let me put a boundary here. Let's say I want to interpret this guy now, and I want to interpret this guy. Okay, and don't forget, this is a log odd, right? This is a log odd, right? What am I going to do? Okay, if I want to interpret, let's say I want to interpret this guy now, you know what I'm going to say? Okay, after holding smoking at constant, okay, for every unit increase in age, okay, for every unit increase in age, okay, so you have to say the log odd, okay, decreases. You know, when you take it, the log odd of surviving or the log odd of being alive, okay, decreases by 0.12. I'm going to say that again. Okay, after adjusting for smoking, don't forget this is what you have here now is what we call multiple logistic regression. You know why? Because we have more than one predator. Okay, you have more than one predator. Okay, if I want to interpret this guy now, I'm going to say after holding smoking at constant, for every unit increase in age, okay, the log odd of surviving, that is of being alive, the log odd of being alive, okay, is actually 0.12. Okay, the log odd of being alive. So, decreases, because of the negative, you can say decreases by 0.12. If you see a plus here, it's going to be increases by that. So the log odd of being alive decreases. Okay, look at the way I said. I'm going to say that again. I think I'm going to take you back a little bit for you to be able to understand what I'm trying to talk about. Now I'm going to take you back. Now take a look at this. How do we interpret this the other time? We said the log odd of having O-ring damage is expected to decrease by that. Now I'm also going to say the log odd of being alive, okay? The log odd of being alive, the log odd of being alive, okay? So after adjusting for smoking, when age increases by 1, the log odd of being alive actually decreases by 0.12. It's expected to decrease by 0.12. I wanted to take note of that, okay? I wanted to take note of that. Now, if you want to interpret this guy now, you know what you're going to say? The second one, then you're going to say, when you want to look at the log odd of being alive, okay? When, when you go from smoker yes to smoker no, I'm going to say it again. Right now, this is smoker yes, right? Okay. What is the log odd of being alive? Okay. If we go from smoker yes to smoker no, like to somebody who doesn't smoke, what is the log of being alive? If then we have to hold age at a constant. We have to hold age at a constant. So you're going to say after holding age at a constant, okay, and when you move from the smoker yes to smoker no, okay, the expected, it's expected that the log odd of being alive is actually going to decrease by 0.20. That's what we mean. Take a look at that. Okay, negative. Take a look at that. Now, but if you now want to talk about the horse now, interpretation on horse, if you take a look at this now, we now want to consider interpretation on hard. And if we want to consider interpretation on hard, what did we say the other time? We said we're going to use exponential raised to power beta 1, okay, minus 1, then the absolute term. That's exactly what you are doing here. When you get a negative of this, okay, you've put the absolute value. That would be 0.11. If you multiply 0.11 by 100, that will give you 11%. So which means, okay, when you make an attempt, okay, to adjust, okay, holding smoking status constant, okay, holding smoking status constant, when age increases by 1 year, okay, when age increases by 1 year, don't forget the unit of age is in year, right? When age goes up by 1, then the odds, I'm not talking about log odd now, I'm talking about odds of survivor is expected to decrease by 11%. How do I know that it's going to be a decrease? Don't forget, I told you, when you take a look at this, it's negative, right? And I told you the other time, the log odd, the odd, the probability, they are going to be the same direction. And that was how you got that now. That's how you got that 11%. Is there anyone any clarification on that? Okay, is there anyone? Why got that? Okay, now how do we interpret this guy now? The negative is 0.20. We want to interpret the negative is 0.20 in the odd perspective. From the odd perspective, the way we're going to interpret that in the odd perspective is meant from the way it will be interpreted in the log odd perspective. Now, let me tell you, in the log odd perspective, okay, after adjusting for age, okay, now when you go from the smoker yeah to smoker no, okay, the log odd of surviving is expected to decrease by 0.20. That is from the log odd perspective. But if I want to say that from the odd, now I'm in odd now, okay? If I want to say that from the odd, don't forget that formula. Exponential raised to the power beta, whatever it is the coefficient, minus 1. You're going to take the absolute value, don't forget. Okay, now you're just going to be that, and you got that, and that is a negative, right? Okay, absolute value of that would be 0.18, multiplied that by 100, that's going to be 18%. And what you're going to say now, holding age constant when compared to the non-smokers, don't forget, compared to non-smokers, let me tell you this. It's like moving from a smoker to non-smoker, because when you are talking about the categorical period of variable, of course, the one that is showing up, you're actually going to compare the one that is showing on your output, to the one that is not showing up. The one that is showing up is smoker, yes. The one that is not showing up, that we call smoker no, is being referenced. And if you want to make, if you want to interpret, you're basically going to be comparing that relative to the other one. So holding age constant when compared to the non-smoker, the odds of survival for smokers is expected to decrease by 18%. Take a look at that. Is there anyone who have any trouble with that? Is there anyone? Now you're basically going to see what I'm interpreting here is odds. Okay, I'm actually, interpreting odds. And you know what I got the odds? You can get the odds from the log odd. Okay, I just wanted to take note of that. The odds, the log odd, I told you the other time, the log odd and the probability form, they are the usual two ways of experiencing logistic regression model. But the fact remains, when we want to relate, when we want to take a practical, interpretation or decision, and we're always going to refer to the odds. Okay, we're always going to refer to the odds. I just wanted to take note of that. What we're interpreting here now, we're basically interpreting odds. Okay, the odds of what? The odds of surviving. That is exactly what I'm doing now. I believe you get that now. Okay. Okay, so that is what we got about that. Now, if you now want to have the generate the plot now, okay, this is the way the plot is basically going to be, okay, for this multiple logistic regression model. We already have the logic form of that, the one I call the log odd. And of course, I think I've just walked you through how you can actually interpret each of that. And don't forget, when you have more than one predator, of course, if you want to interpret the slope associated with one, you basically need to first skip the other one at constant. Okay, so looking at the expression here now, so when you hold age constant, the smokers have a smaller log odds for survival than non-smokers. If you take a look at that, so therefore the smokers have a smaller probability for surviving than non-smokers. That is exactly what it's trying to say. But you may decide to say, okay, let's just do this. Okay, let's say that we have somebody at age 60 now, okay, and you plug that in. into the age. Look at that now. And let's say the person actually smoke. Okay, when the person smoke, I'm going to plug in 1, right? We're plugging 1 here, right? 1 multiplied by that, that's why. So at the end of the day, okay, the log of that, the log odd of this actually gives 0.2, right? If I want to calculate the probability, you know what I'm going to do? I can actually solve for y cap here, right? Which is going to give me 0.55. Look at that. But let me tell you this, I have a code that I'm actually going to walk you through on Friday on how to implement logistic regression in R. Okay, you don't necessarily need to go and calculate using the manual approach. Okay, with a simple code, we can actually, just like the way we handle linear regression with our codes. I'm also going to, unfold that, on Friday. So, somebody who smoke and the age is 60, okay, by the time you don't forget who smoke, yes, you're going to plug in 1. Don't forget, plug in 1, you calculate that, and you get this as a log odd. The log odd is 0.2. Okay. I want to ask this question now. If this guy, is a log odd, don't forget, that is a log odd, right? The log odd of that person is 0.2. Okay. When they say the log odd, they're like you have a 0.2 here. Can somebody tell me if I want to get odd, what am I going to do? If I have a log odd, okay, calculated as a 0.2. And maybe I'm not interested in log odd. Okay, I'm interested in odd. What am I gonna do? Can somebody tell me what I'm gonna do if I want to get odd from here now? I get the log odd, right? The log of odd to be 0.2. Okay, the log of odd is 0.2. Now, what am I gonna do to that to get odd? If I really I just want to see for extra credit. We want to answer that for extra credit. If the log odd is a 0.2, what is going to be the odd? How am I going to get odd? Don't forget, take a look at this. What is it? Log of something. In mathematics, if the log of x equal to 2, how will you, and somebody now say, okay,
If you
how
just raise it to the power of e,
you're going to
e
raise what?
to e to the equation.
Oh, do you say e raised to power 0.2?
Yeah,
Okay, I just want to see whether you mean this. Do you mean exponential raised to power 0.2, what I wrote here? Do you mean this?
yeah, that's how, from the log equals 2. That's how you get rid of the log, right?
Yeah,
But are
yeah,
you trying to?
yeah. If this is what you mean, then you are right. Okay, because you are coming from the log. When log crosses, it's going to be exponential. Don't forget here now, the whole of this, we simplify that to be 0.2. If I want to drop the log and I only want to talk about the odd ratio, this guy is the odd ratio that I'm talking about. You see that? That's the odd ratio. So the odd is now going to be exponential raised to power 0.2. So you are right. Okay, when you do 0 exponential raised to power, that is basically going to give you your odd. So good job. Send a message to me for extra credit. Now you know what I'm trying to tell the world now. The probability, okay, of somebody being of surviving for somebody who smoke is a 0.55. Look at that. Now let us now consider somebody the same, maybe another person at that same age. Okay, that same age, but this person does not smoke. Okay, you see here, right? Why am I plugging in 0? Okay, for what? For smoker, yes. When smoker, yes, equal to 0, it means the person does not smoke. But when you take a look at this, I'm seeing maintaining 60 as age. Okay, now we now want to compute what would be the log odd, what would be the odd, and what would be the probability. So that will give us an opportunity to compare the probability of somebody who smoke and somebody who do not smoke, and they have the same age, we can actually compare the probability that they basically going to be alive. Now, that's exactly what we're trying to do here now. Okay, we plug in 0, and by the time we simplify this guy, the log odd, if you take a look at what I have now, don't forget, I've already switched. Here it was smoker against not smoker, but now I started with not smoker against smoker. I wanted to take a look at what I wrote now. Here it is smoker against 1 minus that probability of smoker, which is more or less like smoker against non-smoker. But here it is not smoker against smoker, right? Okay. Now I got a 0.55 for somebody at age 60 who smoke. Okay. And I got this as a odd ratio. As a log odd. Okay. And look at what I got as a log odd for somebody who did not smoke at the same age. And look at what I got as a probability of surviving. Now, when you compare the two now, you're basically going to compare this guy with this guy. Look at that. Now, which one is the one that have that is more likely to be alive is a non-smoker. Look at that. Because 0.6 is greater than 0.55. And don't forget, we actually want to figure out the probability of being alive, okay, the probability of surviving. So which means, the smokers actually have a lower probability of surviving compared to non-smokers. That is exactly what we're trying to say. That is what we actually figure out now. Okay, don't forget, we actually consider those in the same class of age, 60. Okay, the only thing that we actually, that can differentiate them is that some smoke and some do not smoke. And we decided to figure out what will be the probability that they're going to be alive. Okay, that is what we just figure out now. That's what we just did. Take a look at that. Okay, is there anyone who need a clarification on this? Is there anyone? Like I said on Friday, I'm actually going to walk you through this in the lab session, how you can actually implement the logistic regression in R. We're still going to continue with the logistic regression tomorrow. Like this is where I'm actually going to stop today. Like I said, today I introduce you to, I think we continue with what we started yesterday on the logistic regression model. And today I walk you through simple logistic and multiple logistic. Now the simple logistic is when you have one predator and the response variable is categorical. And the multiple logistic is when you have more than one predator and the response variable is categorical. Okay, I remember when I was actually walking you through this, the one on, the two predator that I'm working on, where we are trying to look at the effect of age and smoking on mortality. Okay, I think I actually walk you through that. And I also walk you through a simple logistic where we're looking at the effect of temperature on whether O-ring that was launched is going to be damaged or not. And of course, I walk you through how you can actually write out the fitted logistic regression model, the logger, the HOD, and the probability, and how the model coefficient can actually be interpreted. Okay, and of course, what we did finally was where we look at the effect of age and smoking on, whether somebody is going to be alive or not. And I actually walk you through an example where 20 years, some women were interviewed and they asked them whether they smoke or not. They put into consideration their age at the first interview. their age was recorded at the first interview, and after 20 years later, they actually did a follow-up to see whether they are still alive or not. And of course, we fitted a logistic regression model. And of course, from what you can see from logistic regression model is basically trying to tell us that smoking actually has effects on the probability of being alive. Of course, I gave you an example where we actually consider somebody of age 60 and somebody who is of age 60 and he smoked and the other one doesn't smoke. And of course, by the time we plug in that into the logistic regression model, the log odd is different. And at the same time, the probability associated with that is different. Of course, we got 0.55 for there as the probability of being alive for somebody who smoke, and 0.60 as the probability of somebody who do not smoke being alive. And of course, we're able to establish the fact that the smokers actually have a smaller probability for survival than non-smokers. This is more or less what I was talking about the other time, that we find ourselves in a world where we need information to understand the world. We don't want to take a wrong decision at the end of the day. And what is basically going to save the day is when you actually, uh, you know, conduct statistical analysis, okay, you'll be able to be guided, you'll be able to know what kind of model you're actually going to fit. And at the end of the day, you basically, based on the empirical evidence, of course, based on the empirical evidence, you'll be able to tell the world what you see, okay? You tell the world what you see, we're telling the world what we see now. This is not politically fabricated, but this is, empirical base, like evidence from scientific point of view, okay, using the statistical framework. Okay, is there anyone who need clarification before I go today? Is there anyone? Okay, in the absence of that, I'm gonna say, I'm gonna repeat what I said when I started. There's not gonna be assignment this week. Initially, I delayed the posting of assignment uh, to Tuesday, but I realized that when I go with a plan, I'm actually gonna disrupt your activity. You are used to Sunday. Of course, the reason why I delay assignment in the first place is just for you to concentrate, celebrating the independence. Okay. So I'm actually going to advise that you use this opportunity to revise on what you've done before, okay, in the preparation for the midterm too. Okay, so I want to appreciate every one of you who have attended my lecture today. I hope you're enjoying it. Until tomorrow, then I'm actually going to come your way again. Make sure you stay safe and have a very lovely day. So bye for now, everyone.